Okay, it is the test on Newton laws, right? Newton laws. So we are basically going to explain how to apply F equals ma and F equals mv minus mu divided by t, and F equals m over t times v minus u. So that is the same equation, but there are different ways that you are going to use it. It is just basically the same idea, right? Right. We'll move on to the first question. Consider the expressions below about action and reaction forces. So Newton's third law. So it's a very simple law to say, but many students have misunderstood that, doesn't understand perfectly. So action and reaction forces. Every force has an equal and opposite action and reaction force, but it doesn't fully explain what it means, right? They understand it has, you understand that the objects has the action and reaction forces are equal and opposite. That you understand, but how they applied is what you don't understand. Let's say this object, so when they collide, this object causes a force on here. Let's say A and B. Then this object causes a force on B. These are action and reaction forces, equal and opposite. But the forces are not acting on the same object, right? So when they collide, this object causes a force on B, right? So this is by B on A. This force by created by A on B, right? So these are on B and this is on A. They are not acting on the same object. They are always acts on two different objects. So all the forces are like that. If you think about any force, it always has a reaction force. There are no forces that does not have a reaction force. Any force you can think has a reaction force, right? But when you are solving problems, sometimes if it is not necessary, you can disregard the reaction force, right? So when you are drawing a free body diagram, usually you disregard those reaction forces. You don't include both action and reaction forces because you are only putting the forces, you are indicating only the forces acting on a certain object. You are not you are not indicating other forces, but always there's the reaction force. Remember that, right? Always this force. So that is the Newton's third law. Every force has an equal and opposite reaction force. They are always on each other, right? They are not acting on the same object. Okay. So to find the reaction force, you can always change this preposition. Let's say there's a force by B on A. Then to find the reaction force, if it is hard to imagine the reaction force, all you have to do is just change these prepositions, right? Or change the object, right? Then there's always going to be a reaction force like that. So the answer is going to be A is equal in magnitude, correct. Directions are opposite, correct. Wrong one is they act on the same object. They don't, right? Right. So the answer should be A and C. Okay. Then we'll move on to the second question. As shown by the image, a roller weighing 500 kilograms, moving at speed 1 meters per second, hits on a wall and stops within 0.5 seconds. So initially, there's this object and it has 500 kilogram. Due to its, since it has a velocity, it has a momentum. So it hits the wall. So let's say it hits the wall like this. So as it hits the wall, the wall exerts a force on the object. Due to that force, the object stops. You can just apply the equations, and if you know the equation, you can simply get the answer, right? But I need to emphasize here, you have to be careful about the directions as well. That is the point there, right? But to get the answer, you don't need to think that much, but this will be useful. Think about how I'm going to use this. So whenever you apply this equation, it is always you are applying that to a certain object. Here I am applying to 500 kilogram, right? Meaning the object. I am applying that to the 500 kilogram. So you have to consider all the forces on 500 kilogram and the direction is horizontal. I am applying to this direction. So the force is acted to this direction. I have marked the force exerted by wall on the object to this direction. So I have to put it as a minus sign, minus F, because you are applying the equation to this side, right? And the force is to this side. Okay? Right. So what's the final momentum? It stops, right? So final momentum is 0. Initial momentum, that is 500 times initial velocity, that is 1. It is to this direction, so positive value that. This negative sign is in the equation, right? Divided by time. So the time they have given as 0.5 seconds. So this momentum change happens within a 0.5 seconds. Then we get negative terms. Then you can say F equals this 0 point is half, right? So when it goes up, it becomes 2, 500 times 2. So it is 1000 Newton. So you got anyone can get this value if you know the equation. Just do the substitution. But you have to think about directions, right? This is the essence here. So you got a positive value for force. So what does it mean? When you get a positive value for a term you get, the direction you have put is correct. That's what it means. When you get a positive, if it is wrong, you get a negative value. We don't know whether the object, here it is obvious, but for a complicated question, we would not know the direction of the unknown force, right? But for this one, it is obvious. But it doesn't matter if you got the wrong direction, but if you got the negative value, you can say, direction is not direction, it is to the opposite direction. But here you have got a positive value, meaning the direction we took is correct. So the direction of the force acted on the 500 kilogram is to this direction. So if you think about these are very useful. You have to think about these directions when you are doing a complicated question, right? When you are doing a complicated question, you can always get the correct answer. But for this one, you just have to do the substitution and get the answer, because they are only asking about the magnitude here, right? But remember, this is the accurate way how to apply that equation. There's always something that you have to put the equation, right? You have to specify that. That is 500 kilogram. Then you put a direction, right? To this direction. You can put the direction to the other side as well, but the equation signs changes in that, but finally you get the correct answer. So I just put the direction and you got the answer. And if the answer is positive, you get a positive value for the answer. The direction you assert for the unknown force is correct. That's what it means. If you get a negative answer, you have to say, the direction is not direction, it should be the other direction. Right. Right, third question. A football player hits a ball with mass 1 kilogram, which moves towards him. Let's say football player is here, and there's the ball. It has a 1 kilogram mass, moving towards him at 10 meters per second, and he hits the ball, and the ball bounces back at 15 meters per second, right? So as the ball collides on the foot of the player, the foot exerts a force to this direction. Got it? To this direction, right? The ball applies a force to the foot as well. Those are action-reaction forces. But you don't have to worry about this because I'm applying equation to the ball, right? So you don't have to worry about this reaction force. So I have to correctly understand how to apply this theory. Anyone can just take the answer, right? Doing the substitution. But you have to understand correctly. It will be useful whenever you are dealing with a complicated question, right? Okay. So let's specify to which. So I'm applying this to 2 kilogram. So for an essay question, you need to write this, right? Sometimes they give you marks for this. To 1 kilogram, and the direction is to this direction. Force I marked to this F, mv minus mu divided by time. Final momentum, that is 15, 1 times 15. And the direction agrees with it, so it is positive value, right? Minus in the equation, then you get mu. Mass is 1. Velocity, it is to the opposite direction. But you apply the equation to this direction. You have to substitute it as a negative value. So it is 10. Divided by time. What's the time? 1 over 50 seconds. 1/50th of a second. Okay? So you can see this minus and this minus becomes plus. 15 plus 10, 25. And this 50, 1 over 50 goes up, flips, becomes 50. So it should be 125, 1250 newtons, right? 1250 newtons of force is applied there. You can clearly see that when the objects moves to opposite directions, like hits and opposite, the momentums of those adds up when you need to find the force, right? For MCQs, that's better. You don't have to worry about these directions for MCQs. But for essay questions, you have to indicate this. You have to think about this. Sometimes, if it seems important, they might give you marks for that. Even though the final answer is wrong, there may be a step here that you would gain some marks, right? So you have to correctly understand these concepts, okay? Right. Okay, fourth question. A hollow plastic sphere with mass 12 kilogram is immersed by attaching it from a string to the bottom of a lake. Given that tension of string is 60 Newton, initial acceleration of the sphere once the string is cut, right? So initially, at first, so it is filled with water, let's say the water level to this side. So you know, when you will learn this perfectly later about upthrust, whenever you sink something, right, let's say, so this is obviously a floating object, right, it tends to go up in liquid. So always that force is called upthrust. You will learn that. So, some of you may have already learned that. So upthrust, it is always upwards. This is the force acted on the object upwards, right? Then the other force, weight of this, let's say mg. And there's the other force, tension. So these are all the forces acting on this object. So this is basically a free body diagram. This is what we call free body diagram, right? If you mention all the forces acting on the system you specify, So that is called what we call the free body diagram. You are not going to put other forces here, right? Let's say there's a T here as well. But if you mention this T, that free, if they specifically ask, then it is wrong, right? You only mention the forces acting on that object or system that you consider. Right. So they have given values here, right? So the mass is 12 kilograms. So the weight should be mg, meaning 120 Newton. This is the weight. They have given the tension as well as 60 Newton. This is the tension. So obviously this is not moving. So you can say you can apply F equals ma. So the to upwards it is u, downwards minus 120 and 60. No motion, so 0. So u is equal to 180 Newton. So in this case we found upthrust. It is just to find the upthrust, right? Okay. Then what they say is the string is cut off. So the tension is gone, right? So no longer the weight of the ball can balance the upthrust, because upthrust is 180 Newton. Upthrust doesn't change. Upthrust is dependent on the volume, density, and G. Cutting the string doesn't change the upthrust. So the string is no longer there. So there's an unbalanced force which accelerates this upwards. So let's say upwards 180, downwards 120. Mass is 12 and acceleration. So this is 60 equals 12a. So acceleration should be 5 meters per square second. Right? So this is how you find it. So this first part is given you to find the upthrust acting on the object. Right? So under any situation, if you follow the correct steps, if you think about the direction, the free body diagram, the forces acting on them correctly, you will always get the correct answer, right? Then the fifth question, a mass 0.3 kilogram, 0.3 kilogram is accelerated by a spring with a spring constant 15 newtons per meter, and the spring is compressed, right? So the compression of the spring is 0.20 centimeters. I'll convert that into meters. So it is 0.2 meters of compression. So in a spring, this is spring constant, and X, spring constant is given as 15 newtons per meter, right? So compressed amount or extended amount is simple X. So when you substitute that, you can find the tension or the force builds up in the spring. So this is 15, X is 0.2. 15 times 2 is 30. There's a decimal, 1 point, so it should be 3. Right? There are some students, when you take a calculation like this, they do it separately, right? But you have to follow these shortcut methods when you are doing calculations. It will save time, right? If you are going to waste too much time on calculations, certainly you won't have enough time to do all the questions in a paper. So you have to have that skill as well, right? You have to follow the shortcut methods when you are doing the calculations. You have to practice those calculations as well, right? I have seen that many students waste a huge amount of time doing calculations. There are many ways you can simply get the answer, but follow a very long method, like follow those steps as in O levels, and waste a lot of time there. So you have to be careful when you are doing calculations, right? You have to practice it. You cannot just take that practice overnight. When you are doing calculations more and more, You have to follow those practices. Always look for a shortcut method to get the answer. Because for the calculations, they don't give you marks for writing in steps, right? So 15 times 2 plus 30, there's a decimal, so it should be 3 Newton, right? So we found the force builds up in the spring, that is 3 Newton. It is exerted on the object. So I'm applying the force F equals ma to this side. So 3 Newton, that is the only force. Mass is 0.3, acceleration. 1, I just divide by 1. 1 over 0.1. Okay? So 0.1 means 1 over 10. So it flips. Right? You need to avoid as much as possible these calculation steps. Okay? There are many things you can do, those calculations, you can do them in your head. You have to practice those. Don't be afraid to do that. You have to do many of them. After this, after substitution, you should be able to get the answer as 10. Right? Actually, you don't need to write this step even. Okay? Those are the reasons why you're running out of time as you're doing a paper or something, right? It comes with the practice. It doesn't come overnight, okay? Right? Like you have to practice those shortcuts, right? Those are not actual shortcuts. Don't write too many things, too many calculation steps. I have seen that. Avoid that, right? As much as possible, but you need to get the correct answer, right? Okay. Okay, sixth question. A monkey weighing 20 kilogram. So let's say there's the monkey like this, right? And he is weighing 20 kilogram, meaning the weight of the monkey is 200 Newton. Okay? Hanging by a rope. And hanging by a rope is like this. The maximum force that rope can withstand, otherwise the rope would break. They say 25 kilogram, meaning it can bear a load of 250 Newton load. This is the maximum load. So as you to go for the monkey to accelerate upwards, it has to exert a force, and that maximum force should be 250 Newton. This force is on the monkey, right? The monkey is applying a force on the rope downwards. The rope applies a force on the monkey upwards. I have drawn only a free body diagram for the monkey, right? Not for the rope. We are not concerned about the rope. We are finding the acceleration of the monkey, right? So you are only including all the forces on the monkey. So weight is on the monkey. This force is on the monkey. Don't mark this 250 downwards, right? That 250 is on the rope. We don't have to consider about the rope. Okay. So 250 on the monkey. Those are action reaction forces. You have chosen only. Here you have got only a reaction force, right? So the only forces are these two on the monkey. So just apply F equals ma upwards. 250 minus 200 equals mass of the monkey, acceleration. 50, you get 50 divided by 20. Cancel. 5 divided by 2. Do you have to write below 5 divided by 2? They don't give marks for writing this stuff, right? You can do that to your head. 5 divided by 2 is 2.5. And the unit should be meters per square second. Okay? Right. Right. Then the seventh question. when a man with weight W with a parachute lands, acceleration of 3g acts upwards on him, right? So let's say there's the man. There's a parachute as well, it doesn't matter. As he lands, right? Lands means as the moment he contacts the floor, there's the normal reaction force. So you are applying F equals ma to this instant. So that's the difference of this question, right? You have to understand that for this question. The moment he's in contact with the flow, right? The reaction force acts of is R. This reaction force is what causes a 3g acceleration upwards. Okay. Unlike in the previous questions, for the previous questions, we didn't have to think about applying F equals ma like for a moment, right? Because for a while, we can think about object having the same acceleration. But in this case, this acceleration, this 3g, is in the moment the man lands here. It is not while man is landing. It is the moment man lands on the floor, right? At that moment, there's a 3g acceleration upwards. It is not the only force, so there's a weight of the man as well. It doesn't change, right? Weight of the man and the R. Now just apply F equals ma. In this moment, the man has a 3g acceleration, right? Upwards. So the forces are R upwards, downwards W mg. The man with weight W, right? Man has a weight W, okay? Weight of the man is W. So let's say mass is M. So W, you have to take the answer in W. So R minus W. So what is the mass of the man? How do you find that? W always equal to mg, m times gravitational acceleration. So if you want to find the mass, it is W divided by G, right? So mass W divided by G times, in this moment, acceleration upwards, it is 3G. D cancels off. 3W, that's 3W. You need to write the answer in the next step, right? Don't write unnecessary steps. So this is 3W. Here minus W. Just put it to the other side, it becomes plus. 3 plus 1, it is 4W. So this is the normal reaction force as he lands acting on the man. So after a while, after this moment, this normal reaction force would decrease, right? Because now the man stops completely and the normal reaction force decreases to W. W and R should be equal. But in this moment, the moment he lands, to stop the man, there's a higher normal reaction force acting on the man. It is equal to 4W. Okay, so you have to understand these concepts. Not just applying equations, right? You should be able to do any question. If you understand this correctly, the theory, for any complicated question, you will get the answer there, right? Next question, 8. An object with mass 100 gram is hanging by a thread. 100 gram means 0.1 kilogram, right? 100 gram. There's a thread, 0.1 kilogram, meaning weight is 1 Newton. First, the object is accelerates upwards, so there's tension, upwards tension, and it is accelerating upwards at 5 meters per square second, right? And the tension is Tu. Then the object is accelerated downwards. And as you are doing that, tension acting on the object, they say TD, and it is moving downwards, right? 5 meters per square second. Weight is always there. It is 5 meters per square second, right? This is what happens. So you can see the tension should, if you are lowering the object at a certain acceleration, the tension should decrease, right? Here, tension is higher. We'll see, just apply F equals ma to this. So tu minus 1, tu upwards minus 1 equals 0.1, acceleration 5. So you can find tu, 0.1 times 5, 0.5. Minus 1 goes to the other side, 1. 1 plus 0. So it is 1.5 Newton. Right, then apply F equals ma downwards, 1 below, td upwards. So 0.1 kg, acceleration downwards. So it is a positive, right? I apply the equation up downwards, so the acceleration also positive. Here you apply the upwards, acceleration also upwards. That's why you got a positive value, right? So according to this, 0.5, get to the other side, 1 minus 0.5, it is 0.5. So, when you subtract 1 minus half, 0.5 means half, right? You get a half, so 0.5. I have seen students struggle with these kind of simplifications as well, right? Wasting time. These are the skills. So when you see, when I'm like simplifying, you have to catch up those steps as well, and you have to practice those. Okay. Then physics will not be hard. It is not hard, right? There's nothing you have to remember too much. If you correctly understand that, then that's about it, right? Right, ninth question. As shown by the image, two trolleys with mass 3 kg, 6 kg are attached by a string with mass 1 kg, right? So the string has a mass now. Usually earlier stuff, strings didn't have a mass, but in this case it has a mass. Let's see how it is going to affect here, right? That's why we always mention in the questions that it's a light string, like that. But here the string has a mass. So the trolley, it has 3 kg, and the string, there's 20 Newton applied on the 6 kg trolley here. So its system is like this. They're asking about the acceleration and the tension right at the center of the string. Right? Center of the string means half of the string. So one side has 0.5 kg, other side has also 0.5 kg. So when they ask tension, for a light string, tension will be same everywhere. But for a string with mass, tension changes, right? Due to its mass, tension changes from place to place, right? So here what they ask is tension at the middle. You can find the tension anywhere in the. So I have to separate like this. Just put a separation there. Then you have to consider these systems separately, right? But to find the acceleration, so you are applying, usually you apply to find this acceleration of the system, you apply the equation to the whole system. First, let's find the acceleration, then I'll explain how to find the tension to whole system, right? That's why it is important defining these. To whole system, just apply F equals ma. If you think about whole system, the only force acting horizontally on the system is 20 Newton. There's tension here, right? These tensions are becomes internal forces, because when you define the whole system, these becomes internal forces. T here, T there, right? So you don't have to include them. So only force 20. Total mass, it is 3, 6, 9, 1. 10 is the total mass of the system. So the acceleration is 2 meters per square second. That's the acceleration of the system. So each part has the same acceleration, right? 2 meters per square second. Then I'm going to apply this equation. I'm going to apply to this one. You can apply to this part as well, but here I'm applying the equation to this part. It is easy, a bit easy, right? You will get the exact answer if you apply here, but if you apply that equation here, it will be easy because it only has one force here, right? Now carefully understand. At this point, there's a tension, right? So this part is pulled by this part. So the tension at here on the system should be to this direction, T. This tension is on this system, right? Then there's a tension to opposite side acting on this one, action and reaction forces, opposite side. But that force is on this system. We don't have to worry about this system because I'm applying equations to this system, right? So on that system, tension applied by this other system is to the opposite side. So you have to understand that 100%, right? Right. Now on this system, there's going to be tension. Now the tension is going to be an external force, not an internal force. So T. So now the only force on this system is T. There's no any other force. Mass of this system, it is 3.5. Acceleration we found as 2. So it is 7 meters per square second, right? So the tension is 7 meters per square second. So the answer is fourth one, right? 2 meters per square second, 7 Newton. Right. 10th, a uniform rod with length L length L, right? Total length is capital L, is placed on a smooth and applied forces to this side F1. They say F1 is larger, and from the other side there's a force acting F2. Tension at a distance y from the end that F1 force applied is. So F1 force is here. So they are asking tension, let's say y somewhere here. Okay. They are asking about tension here at this point. This rod has a mass, right? So the tension varies along the rod. Okay. So before finding the tension, I need to find the, so I'll just mention the tension. On this part, the tension is to this direction. This tension is on this part, right? Then there's the reaction force, this tension. This tension is on this part, right? Okay. Right. But here I'm applying for the whole rod because I need to find the acceleration of the rod. This is larger, so accelerates to this direction. So the forces are F1 to this side and F2 to this side. These tensions are not included, right? Because these are internal forces. Then the total mass of the rod. The length is given as L. So I'll take the mass as length. capital L. Then acceleration. So you get the acceleration as, I'll just multiply this by a k to make it a mass, right? So F1 minus F2 divided by KL. So KL is the mass. So when you multiply this by a constant, it turns into a mass, right? Because of uniform cross section and uniform density. So you can write the mass as KL. So this is for the acceleration of the system. Right. Okay, we found the acceleration. Then we'll find we need to find the tension. So to find the tension, I'm going to apply, if you can apply to this side, but here I'm going to apply to this side, right? Doesn't matter which side you apply that. I'm applying to this part. Now carefully think about the forces acting on that part. Obviously F1 is on this part, so F1. Which tension is acting on this part? Is it this one or this one? It should be this one, right? Okay. So this part is applying a force to the other side. This part is applying on this part, the tension is to the other side. So this tension, so it is minus T. Mass, I took it as, just multiply that by the same constant. And what's the length? So I'm using length as the mass here. The length of this part is y, right? So it is ky. When you multiply that by a unit, it turns into a mass, right? So acceleration. Acceleration, we already found that. That is this one. F1 minus F2 divided by KL. Do you understand that K cancels off, right? Okay. Then F1 minus, I'm putting T to the other side because you need to find T. You need to single out T. Put the T to the other side, then here becomes Y. F1 minus F2 divided by L. It is equal to tension, T. Okay, let's see what can we do. So you have to form this according to the answers given, right? Okay. So F1 minus, so Y F1 divided by L. Just multiply by, take out the brackets. So Y F1 then divide by L. Minus minus plus, so it is Y F2 divided by L equals T. So you take F1 out of these two. So you have to separate F1 and F2. So when you get F1 out of these two, it becomes 1 minus Y over L. Okay. Plus Y F2 divided by L. So this is the expression for tension. So the answer should be what? First one? Is it the first one? Yeah. Answer is first one, right? In the explanation, written explanation, I have applied F equals ma to this part. In this question, it doesn't matter, right? Which part you are applying that. Complexity is the same. Right. 11th question. When horizontal force F is applied on M1, there's M2 and there's M3. Normal reaction force between M1 and M2 is, plane is smooth. They're asking M1 and M2. So, you know, when this is due to this force, M1 is pressed against M2. M1 is pressed. So M1 applies, these are called normal reaction. Normal reaction means there's normal reaction here as well, but there's no motion to that side, right? So I'm only considering normal reactions horizontally. Normal reaction is whenever there's a contact between two objects, always there's going to be a normal reaction between them, right? So this normal reaction, normal to the surface, acting on M2. Then there's a reaction force on M1, right? So you have the system. You need to find this R. That's what you have to do. You have to find R, right? So under any case, this is a smooth surface. If the friction is involved, this question would be a bit more complicated, but it is a smooth surface, so you don't have to worry about friction. So same as you have to first find the acceleration. That's what we did for all the cases, right? Acceleration of the system. So to system, you have to write this, which you are going to apply in SS, right? You apply to system. F equals ma to this side. Then force. So when you consider the whole system, these forces become internal forces. These forces, these two, they cancel off, right? Only unbalanced force is, external force is this. So it is F. So the mass of the system, you just have to add all the masses, and let's say acceleration, simple A. You need to get rid of A, right? Because that is a term we use, right? Then I'll apply the equation to this part. M2 and M3 together. F equals ma to this side. M2 and M3 together. Together, when you apply that together, what happens is there's a normal reaction here as well. That cancel off, that becomes internal to this system. When you consider this system, there's a normal reaction here, but it cancels off, right? That normal reaction cancel off. That's why you apply that together. Okay, so we have to deal with when you are doing the question, you have to do it as simply as possible. Okay. Okay. When you consider this, the only force acting there is this normal reaction, this capital R horizontally. So that is capital R. So the mass is M2 plus M3 of this system, M2 plus M3. Acceleration is same. This acceleration, right? You can see that acceleration is what? F divided by this mass. F divided by this whole mass. Understood? Here, you just put the whole term there, right? F divided by M1, M2, M3. This is a one term, so you put it, cross multiplied it, and substituted for the acceleration here, right? So that's what you did. Okay, so this should be the answer. So the answer is fourth one, right? M2 plus M3, F divided by M1, M2, M3. Right. 12. Strings are inextensible and light. Right? M2, M3 greater than M1. Tension of the string is. Now they haven't specified which string, right? They haven't specified which string. Actually, that string should be it should be corrected, right? 12th one. You actually have to find the string, the tension between M2 and M3. It should be mentioned in the question, right? Okay. So you have this pulley system M1. So the tension, there's M2 and M3. So both sides, since these are light strings, both sides have the same tension. But this is a different part, so it has a different tension. T1 on this one, T1 on this one. So there's M2G weight here, and there's M3G weight here. So all the forces here is marked, all the forces here is marked, and all the forces here also is marked. Right. So this is the these are the forces we require. Right. So obviously the system is going to accelerate to this side, because the question says the mass of these two is greater. And the other side, it goes up. Right. Okay. So this is what I'm going to do. First, I'm going to apply M to M1 upwards. So what are the forces on M1? T minus M1G equals M1, acceleration is A. Okay. Then I'm going to apply the equation to M2 and M3 together. Because before finding, actually we need to find T1. In order to find T1, first you need to find the acceleration of the system. Without that, other quantities cannot be found, right? So you have to find the acceleration first. So that is the easy way. So to find that, I'm applying M2 and M3 together, right? So when you get it together, this T1, T2, these two forces becomes internal forces. Understand? These are forces exerted by within the object. These M2G and M3G, those are forces exerted by the earth, right? So earth is an external object. So you have to include these forces, M2G, M3G. But the tensions gets rid of this tension, T1, T2. But this tension is here because it is exerted by an external object, which is the remaining part of the string. Right. So you don't have to think about these two. So what are the forces? I'll just apply downwards, F equals ma. So the weight is m2g plus m3g. Right? This T1 you can get rid of that, and the tension T is upwards, minus T equals M2 plus M3, right? Times acceleration. So let's say this is the first equation, second equation. So 1 plus 2, what do you get? You can see that plus T minus T cancels off. You have to add those. So becomes M2G plus M3G minus M1G. Right? These two cancels off when you add that. Equals, here it becomes M1 plus M2 plus M3 simple A. Right? So from this, you can get an expression for simple A. That's the acceleration of the system. System means individual objects, right? So M2 plus M3 minus M1, take G out, divided by M1 plus M2 plus M3. This is the acceleration. Okay, now we found the acceleration. You know, in most cases, you first have to find the acceleration, right? Whenever you get a somewhat complicated system. Right, you found the acceleration. Then you can find T1 easily. To find T1, I will just apply the equation to this, to M3. Right? So when you think about only M3, then T1 becomes an external force. Right? T1 is exerted by other part of the system, other part of the string. It is outside of the system. Right? So you need to apply T1. Downwards, the force is applied by Earth, that is M3G. External object, right? Earth is not included in this system, we specify. So M3G downwards minus T1 upwards equals M3 acceleration A. Here you need to find T1. So M3G minus M3A equals T1, right? So you can take M3 out. So inside it is G minus A equals T1, right? So when you are doing these calculations, like clearly this looks complicated, right? When you apply that, but these are just simply, you are just doing simplifications, right? But when you are doing these calculations, you should have like a clear method that this is what you are going to do, right? All you have to do is just substitute instead of A in order to find T1. Let's see how to do that. T1 equals M3 G minus, simple A means that one, right? M2 M3 minus M1 divided by M1 M2 M3 G. You can take G out as well, right? Because both terms has G, both terms have G, you can take it out. It becomes 1 minus M2 plus M3 minus M1 divided by M1, 2, 3. Take the denominator M1, M2, M3. So this becomes M1 plus M2 plus M3. This one becomes this one, right? Minus, there's a minus, multiply this, minus M2 minus M3 plus M1. These are simple, looks complicated, right? But we are doing the same as like doing this stuff, right? Times 2, same thing, right? M2, M3 cancels off. M1, M2, M1 and M1 becomes 2M1. 2M1 and multiply that by M3G. They divide by M1, M2, M3. This is the tension between M2 and M3. Okay. So the answer should be M1, M3. First one, right? First one. The 12th, it is M1, M3, right? Yeah, no, not the first one. It should be second one, right? M1, M3G. It is the second one. Right. So when if you get a question and it feels complicated to you, right? At different times, you can do that at least 2 times, right? Just mark those questions. Then you can. So those questions are where you lack your skills. So you at least you'd have to do 2 times that question. So you can get rid of those lacking areas, lacking skills, right? You can develop those skills. The practice is what makes that, but you have to work hard for it, right? Just doing nothing is not going to do any good for you. So you have to take that actions, right? You have to work hard for it. Right, 13th question. A liquid with density rho is incident on a wall at V. Let's say this is coming from a, it is incident at V and jumps off at V over 2. Cross-sectional area is given as A of the fluid. Force applied on wall by the fluid. So as it hits the wall as it hits the wall, the fluid applies a force on the wall. This is what they ask. But the reaction force is on the fluid. They are equal in magnitude, right? So they are only asking about a magnitude. So I'll just get this F, right? This question is not hard, but let's correctly apply directions as well, right? So to fluid, I'm applying this to fluid. I'll apply to this direction. You can apply to other direction as well. So here I'm more concerned about the answer. You can get the answer easily, but I'm more concerned about how to apply this. Right. So the another thing is, so here you have a fluid, right? Fluid flow rate. Fluid flow rate. So in this case, you have to use this form of the equation. You know, mv minus mu divided by t. Take m out. So you apply that here. M over t, v minus u. Okay. So this is the mass flow rate. This is an important concept. For mass flow rate, when you get a question like this, for mass flow rate, you can write AV rho. Right? So what is AV? A is the cross section and V is the velocity. Per second, it moves this distance. And this is cross section. When you multiply these two, it becomes a velocity, right? Sorry, it becomes a volume. AV means volume. This happened within a second. So it is a volume flow rate. You get in cubic meters per second. Volume flow rate. Then when you multiply that by density, you can convert that into a mass flow rate. Per cubic meter cancels off kilograms per second. So this is a mass flow rate, kilograms per second. So you can apply that AV rho is a mass flow rate. AV is a volume flow rate. Here we need the mass flow rate, so it is AV rho. Velocity is V, right? Then final velocity. Final velocity means after it hits the wall. So it is V over 2, right? Not V. It is V over 2. Final means after it hitting the wall. So I'm applying the equation to this side. Since it is to this side, I'm applying to this side. This is a negative. You have to substitute as a negative value. Minus initial. Initial means to this side, right? So it is a positive value. This negative is in the equation, right? Right. Then this force. Force is to this side. So it is minus F. Right. AV rho V over 2 plus V. Right. So for MCQ, you know whenever it bounces off, you have to just take the addition, right? You have to practice this for MCQ. You just have to add those velocities whenever it bounces off. But this is how you get it correctly. For essay question, you would have to show these steps, right? Okay. So AV rho, this is 3V divided by 2. So it should be 3A rho. They have taken 3 rho A V squared divided by 2. Right? So this is the force exerted by this water jet or the fluid jet being incident on the wall. Answer is third one. Right, 14th. A balloon with total weight W falls at acceleration simple A, which is lower than G. Right? So let's say this is the balloon. and has a weight W. Accelerates downward at A, right? Here also, the air also is a fluid, right? So whenever there's a fluid, there's always upthrust. U. So if there's no air, you can neglect the upthrust, but in this case, they mention the upthrust. So be careful of the upthrust. Right. So in this case, it lowers down. So the second case, it goes up. In order for that to go up, the weight of the balloon must be reduced, right? So it is lighter, it would go up due to the upthrust. It is not being changed. So let's say now the weight of the balloon is W minus W. Let's say amount of the weight of the things removed is simple W. It is written as like omega, right? To mention that simple W. Right, it has omega, right? Otherwise you'd mix these two. So in this case, it is now the weight of the balloon is W minus simple W. If you do that, then they say it moves upwards at this acceleration. So what they ask is an expression for this W for this to happen. First, it lowers at simple A, then it goes upwards at the same acceleration, goes up, right? In order for that to happen, you have to remove some of the weight of the balloon. So then the weight of the balloon becomes W minus simple W. Then just apply F equals ma to these two cases. Then you can find an expression for simple W. So let's first apply it here. Downwards F equals ma. W minus U equals, so the mass of the balloon, right? Mass of the balloon. So you can write it as the W equals, you know that it is equal, let's say mass of the balloon is capital M G. That's the weight, right? That's always weight. So mass is W divided by G, right? Times, and the acceleration they say simple A. This U term is something we put, right? So you need to get rid of that. Keep that in mind. You need to get rid of this U, upthrust. They haven't introduced U there. That term, that U term is not. We added that. So remember that you have to get rid of this one. All the other terms are introduced. Okay, that one. Then you apply F equals ma upwards. What do you get? U minus W minus W. Put a bracket here, right? Because otherwise you would think that this is minus W. This is a plus minus omega W, right? Okay, now the mass is what? Now the weight is W minus simple W, not W, right? So weight, just divide that by gravitational acceleration to make it a mass. Then same acceleration, it goes up, right? So you get two equations, 1 and 2, right? So you have minus U here plus U here. The easiest way to get rid of that is just add these two equations. So plus U minus U cancels off. 1 plus 2, you get W. This cancels off. W. Then you have minus W minus simple W. Right? There's a minus here. Minus equals WA divided by G plus W minus divided by G times A. Okay? Now you just have the equation required to get simple W. You need to single out that, subject that, right? So here you can see W minus capital W, right? Do you see that those two cancels off? Then minus minus plus simple W. Write simple W like omega, okay? Otherwise you would mix these two. Omega minus minus plus. Then I'll WA divided by G. Just get, I'm removing the brackets, multiply and divide. WA divided by G, WA divided by G minus simple WA divided by G, right? So we got these. Can you cancel these two? Can't, right? Because this is capital W, this is simple W. This is capital W, right? See that? That's why when you are writing the same letter, the other letter should be, the shape should be different, right? That's why I put omega here. Right. Here you can just add these two, that becomes 2 capital WA divided by G. Get this term to this side. This becomes A divided by G minus becomes plus. Right? Then take omega out of this. 1 plus A divided by G equals to WA divided by G. Get the, so it becomes G plus A divided by G, omega equals 2WA divided by G. So you need to single out W. This G and G cancels off, right? This G and G. Then what do you get for W? Simple W. 2 capital W A divided by G plus A. Right? So in order for this to happen, the weight you need to remove from the balloon is this much. 2WA divided by G plus A. This much of a weight should be removed. So the answer should be third one, right? The answer is third one. Right, 15th question. 15th, right? Pulley and the plane are smooth, right? Pulley is light when a horizontal force F is applied. Horizontal force F is applied. Acceleration of the pulley is, right? So capital F here, let's say tension is same everywhere, light, inextensible. So tension is same everywhere. There's just tension here. Then I think simple M is the mass. So what they ask is, under these conditions, you need a expression for acceleration of the pulley. So let's take that as simple A, acceleration of the pulley. In this question, what you have to understand is the acceleration of simple M is 2 times this acceleration. That's the only trick here. Trick means a tip here. It is 2A. Do you understand? When the pulley meters, like let's say 1 centimeter, the string from this side gets pulled to 1 centimeter and this side gets pulled to 1 centimeter, right? So when this moves 1 centimeter, the string pulls this one by 2 centimeters. So displacement is twice. So if the acceleration here is simple A, for this one it should be 2A. Understood? not the same acceleration. Then you can apply F equals ma. First I'll apply to the pulley, right? Doesn't matter which one you apply in that. So onto the pulley, to this side it is F, to opposite side it is T, that is 2T equals 0. Why 0? Because this has a 0 mass. Pulley doesn't have a mass, they say. So 0. So F equals 2T. So T equals what? F divided by 2. That is the tension of the string. Then you apply equations to M. Right? So what are the forces? Only this tension, right? Equals mass is simple M. And the acceleration is 2a actually. Acceleration is 2a. Not a, it is 2a. So what they want to ask is this acceleration. They need simple a, right? Not 2a. So from this t is something we added, a term we introduced. So I need to get rid of that. So t is equal to f over 2. Just substitute it here. So it is equal m times 2a. Just this is 2m cross multiply. So acceleration is equal to f divided by 4m. Got it? They ask acceleration, simple a, of the pulley. So it is divided by 2m. So it is f divided by 4m. So that's the acceleration. Okay? Right.